Today, we want to look at integration of partial fractions. So it is integration of partial fractions or integration using the technique of partial fractions. We have an example, x plus 1 divided by x squared plus x minus 12. So the first step I want to take is I want to look at the denominator. And I want to factorize this, and this will give me x minus 3 and x plus 4. So x squared plus x minus 12 is the same as x minus 3 times x minus 4. And why is that important? Because I want to take my partial fractions and I want to take my integral and I want to break it down into partial fractions. So that's what I want to do. And that will make it easier for me. So I'm going to introduce two unknowns and I'm going to solve them so that I'll be able to break down my equation. So that's the first step. And then I want to multiply it through by this. I want to multiply it through by this. So it will be x plus 1 is equals to x plus 4 a plus x minus 3 b. So that's the first step. I multiply it through with x minus 3 and then I multiply with x plus 4. And then I'll open up the brackets. So I'll have x plus 1 is equals to ax plus bx plus 4a minus 3b. So what have I done? I have put like terms together. And so why is that important? Because I want to compare similar terms together. And that will make it easier for me. So you can see the components without the x, I put them together, and the components with the x term, I put them together. So I can comfortably say for the first equation, it is ax plus bx. And if I divide it through by x, it implies that a plus b is equals to 1. And then in the second equation, 1 is equals to 4a minus 3b. So therefore, I have two equations. I have one here, and I have my second equation there. So I have those two equations that I'm going to use to be able to solve for a and b. And that will make it very easy for me to be able to solve, to get my two partial fractions. So when I put my two equations together, this is what I'll get. I'll get a plus b is equals to 1, and for a minus 3b is equals to 1. I make them the same by multiplying through. In the first equation by 3, 3a plus 3b is equals to 3, and 4a minus 3b is equals to 1. Why did I multiply the first equation by 3? So that I make the parameter or the letter b to be equal in the first and the second equation. But when I sum them up, what happens? I'll get 7a is equals to 4. So comfortably, a is equals to 4 over 7. And b is equals to 1 minus a, which is 1 minus 4 over 7, which is 3 over 7. And now remember how we wrote down our equation at the beginning. We said that x plus 1 over x minus 3, x plus 4 should be equals to 4 over 7, 1 over x minus 3, plus 3 over 7, 1 over x minus 4, or x plus 4. So already I've been able to break down my integral into two partial fractions, a and b. So instead of doing the integral of this I'll do the integral of this, and then I'll just introduce the dx into each of them. And that's how I'll go about it, and that will make it easier. Or as we are familiar with how to do the integral of that, and therefore the integral of x plus 1, x squared plus x minus 12 dx will be equals to 4 over 7 ln of x minus 3 plus 3 over 7 ln of x plus 4, and then plus c. And that gives me the solution of that. Again, if you like my videos, kindly subscribe so that you continue to receive more updates of the videos as we move along and get newer videos every day.